In this video, we are going to learn how to solve these JAMB Physics repeated questions under the subtopic Propagation of sound wave in sound wave. Alright, so we are going to practice with 18 repeated questions for this subtopic. Let's get started. The first question I have here says, which of the following will produce the loudest sound? We have 18 short string, we have B 18 long string, we have C a thick short string, we have D a thick long string. So guys, the correct option to this question is option D, which is a thick long string. Alright, the next question is this one. It says, when a sound wave passes through air into water, the speed and frequency increase, but its wavelength remain the same. This is wrong. The speed and wavelength decrease, but its frequency remain the same. This is also wrong. Speed and wavelength increase, but its frequency remain the same. This is correct. Option C is the right option this question, not option D. Option D says speed remain the same, but its wavelength and frequency increase. No. So speed and wavelength increase, but its frequency remain the same is the right option to this question. Next repeated question is going to be this question. So it says, in a closed organ pipe producing a musical note, an antinode will always be produced at, we have option A, the open end, option B, the middle, the closed end, or the parts of the pipe. The correct option here is option A, which is the open end. Okay, the next repeated question will be this question. It says, if the load at the end of a sonometer wire is immersed in a bucket of water, the original fundamental frequency of the wire could be restored by, we have option A, decrease the length of the wire, increasing the length of the wire, changing the temperature of the wire, increasing the mass per unit length of the wire. So the correct option in this question is option B, which is increasing the length of the wire. Okay, next repeated question will be this question. It says, what is the frequency of vibration if the balance wave of a wristwatch makes 90 revolutions in 25 seconds? So as we all know, the conventional formula for finding frequency is number of oscillation per unit time. Alright, the time here is measured in seconds. So we have in this question the number of oscillation revolution to be 90. To get the frequency, all you need to do is to divide the number of revolution, which is 90 revolution by the time we have here, which is 25 seconds. So when you punch this in the JAMB calculator, you are going to get 3.6 hence. So the correct option here is option A. So 90 divided 25 will give you 3.6 hence. Alright, so the next question will be this question. It says, which of the following is a wind instrument? We have bells, flutes, piano, guitar. The correct option is option B, which is flutes. Flute is a wind instrument. Alright, the next question will be this one. It says, which of the following media allow the transmission of sound waves through them? We have air, liquid, solid. So this question is very, very simple. All of them can allow sound wave to pass through them. So the correct option here is what? Option D, I, and I. So the next video question will be this question. It says, which of the following is a wind instrument? Alright, we have violin, we have harp, we have gong, we have trombone. In the previous question we answered that has similar question style with this one. We had flute to be a wind instrument, but here did not include flute. They instead included trombone. So trombone is also another example of a wind instrument. So the correct option here is option D. Alright, just take note of this particular question, and the other one, the answer was flute. Alright, flute and trombone are examples of wind instrument. Very, very important. Okay, so the next repeated question will be this question. It says, which of the above has a direct relationship with frequency of a vibrating string? So we have tension, we have length, we have mass. So the correct option to this question is option B. That's the right option to this question. So option B, high only tension, is the right answer to this question. The next repeated question will be this question. It says, if a sound wave goes from a cold air region to a hot air region, its wavelength will decrease, then increase, remain constant, decrease. So the correct option in this question is option B, which is increase. The next repeated question will be this question. It says the fundamental frequency of vibration of a sonometer wire may be halved by doubling the mass of the wire, doubling the length of the wire, reducing the absolute temperature by half, reducing the tension by half. The correct option in this question is option B, which is doubling the length of the wire. The next repeated question will be this question. It says the fundamental frequency of vibration of the wire is measured as a function of the tension in the wire, which the following curve adequately represent the data. So the right curve here is this option. So option C. Take note of this particular question, guys. So option C, this is the right representation. Alright, the right curve, option C. So that's it for this question. The next repeated question will be this question. Alright, so it says, what type of wave is emitted by a loudspeaker? We have transverse, radio, longitudinal, gamma. So the correct option to this question is option C, which is longitudinal wave. Okay, take note of this question as well. Next repeated question will be this question. It says, in which of the following material media will sound travel faster? Take note of this particular question. The correct option here is option C, metal. Alright, so sound travels faster in metal than in liquid or in gas. Okay, so the next repeated question will be this question. It says, if the tension in a sonometer is tripled, the ratio of the new frequency to the original frequency is what? Now take note of this question as well. I have solved this question before, so when you solve it, you're going to arrive at square root of 3. Alright, that root 3. The correct option is option D. Take note of it in case it gets repeated. The next question will be this question. It says, which of the following types of wave needs a medium for propagation? So it's obvious. S-ray is an electromagnetic wave, so it's not the right option. Radio wave also electromagnetic, light also electromagnetic. So the correct option is option A, which is sound wave. Alright, sound wave is an example of a mechanical wave that requires a material medium for propagation. Alright, so the next repeated question will be this question. It says, a note is the octave of another note if it has the same frequency as the first note, frequency half that of the first note, a frequency twice that of the first note, a frequency 8 times that of the first note. Take note of this question, guys. The correct option is option C, which is a frequency twice that of the first note. Last question before we call it a class will be this question. It says, sound waves travel through a medium by causing the particles of the medium to vibrate. The direction of vibration of the particles is, take note of this question, option A, in a random direction perpendicular to the direction of the propagation of the wave, no. At an angle to the direction of propagation of the wave, no. Parallel to the direction of propagation of the wave, correct. The right option is option D, parallel to the direction of propagation of the wave. So this is basically how you can do problems involving propagation of sound wave in sound wave for a JAMB Physics. We practice with 18 repeated questions for this subtopic. Hope there's something interesting from the video. Let's go to the video, guys. If you are new to our channel, ensure that you subscribe to this channel by hitting the subscribe button for more of our videos. Also like, share, and comment on this video. Let me know how you feel for what you learned from this video. If you seem to have any specific questions to ask regarding what I've talked about in this video, feel free to leave a question in the comment section below, and I'll ensure to give you a response. Also ensure that you're part of our channel membership by hitting on the join button to become part of the community where you'll be receiving special information that will help to simplify your academic work. Alright, so having done that, click on the screen above and I see you in the next video. Thanks for watching.